Some claim the available options for delivery of toxic dopants to the semiconductor industry are similar in safety while different in costs. These claims don't reveal all the facts. High-pressure and adsorbent-based delivery systems are fundamentally different in terms of safety and risk to personnel. While market prices may differ, review of the facts presented in this animation will reveal SDS cost advantages in material usage, predictable maintenance, and energy savings, with a minor capacity advantage in high-pressure systems. When it comes to handling toxic implant gases, there is no room for relatively safe. Why take on additional risk with little to no cost advantage? With SDS, you can consider obtaining all the safety benefits, essentially for free. Why pay for unused material? With high-pressure, capillary-regulated cylinder packages, gas utilization is poor, with a portion of unused material left behind that the user pays for, caused by the capillary restriction. In contrast, in an adsorbent-based product, you are not charged beyond what the cylinder can deliver. Another inherent design feature of the cylinders that utilize capillaries is that the flow rate drops with little warning when the cylinders are close to endpoint, creating an unpredictable maintenance situation. The flow drops off quickly, leaving the implant tool without dopant and stopping the production process. This stoppage can happen in the middle of an implant step, leading to wafer rework or even potential scrap. With SDS, an empty endpoint takes over 40 times more time to reach, providing a more predictable planned event and reducing any cost associated with a sudden loss of dopant. One of the key functions of implanter ventilation systems is to protect personnel from a high-pressure cylinder toxic gas release. SDS inherent safety enables reducing exhaust flows while eliminating treatment systems and recirculating shell exhaust back to the fab, reducing energy consumption by as much as 80% and reducing carbon footprint up to 3,500 metric tons of CO2 per year. Incorporating an SDS-designed implanter ventilation configuration in constructing a new fab would save approximately $1 to $4 million in capital cost from the reduced sizing and capacity of all the equipment required to produce clean room air. Here is a picture of an actual customer installation where, by changing the implanter ventilation configuration, the customer saved over $250,000 in operating costs and over $400,000 in capital costs at their fab, with a return on investment of less than a year.